7th grade, Unit 2, Lesson 1. One of these things is not like the others. Number 1. Which of these shapes is not like the others? Explain what makes it different by representing each width and height pair with a ratio. The widths are 5 units, 10 units, and 10 units. The heights are 4 units, 8 units, and 6 units. The ratios for the shapes are 5 to 4, 10 to 8, and 10 to 6. The 5 to 4 ratio is equivalent to the 10 to 8 ratio. Because 10 to 6 is not an equivalent ratio with 5 to 4 and 10 to 8, shape C is not like the others. Number 2. In one version of a trail mix, there are 3 cups of peanuts mixed with 2 cups of raisins. In another version of trail mix, there are 4 5/10 cups of peanuts mixed with 3 cups of raisins. Are the ratios equivalent for the 2 mixes? Explain your reasoning. One version of the trail mix has a 3 to 2 ratio, and the other version has a 4 5/10 to 3 ratio. 4 5/10 is the same as 4 1/2, so we could call that a 4 1/2 to 3 ratio. I'm going to illustrate what a 3 to 2 ratio and a 4 5/10 to 3 ratio would look like. The green represents 3 units, and the 2 represents 2 units. On the left, that's a 3 to 2 ratio. On the right, we have a 4 5/10 ratio to 3 ratio. When you compare these two sizes, you can see that 3 is 1 1/2 times larger than 2, and 4 5/10 is 1 1/2 times larger than 3. This illustration shows that 3/2 is the same as 1 1/2, and it also shows that 4 5/10 is 3/2, or 1 1/2 times larger than 3. This illustration also shows that 3 is 3/2, or 1 1/2 times larger than 2. Since 3 times 1 1/2 equals 4 5/10, and 2 times 1 1/2 equals 3, they are equivalent ratios. Number 3. For each object, choose an appropriate scale for a drawing that fits on a regular sheet of paper. Not all of the scales on this list will be used. A person. Well, the average height for an adult person is probably between 5 and 6 feet, so let's use 5 and 6 feet. A 1 inch to 1 foot scale would work. A 6 foot tall person would be drawn 6 inches tall on the scale drawing. B. A football field, 120 yards by 53 1/3 yards. Since a football field is not as long as 1,000 sheets of paper, you could use the scale of 1 to 1,000 and fit the scale drawing of the football field on 1 sheet of paper. C. The state of Washington, which is about 240 miles by 360 miles. Since 360 miles is almost 2 million feet, and 1 piece of paper is almost a foot long, I'm going to pick 7, a scale of 1 to 10 million. D. The floor plan of a house. For a floor plan of a house, I would pick a scale of 1 centimeter to 1 meter. And finally, E. A rectangular farm, 6 miles by 2 miles. For this, I would select 5, a scale of 1 to 100,000. For example, for every 1 inch of the scale drawing on the piece of paper, it would represent 100,000 inches towards the 6 miles in length. There's 380,160 inches in 6 miles. With the scale of 1 to 100,000, you could represent 6 miles with less than 4 inches. Number 4. Which scale is equivalent to 1 centimeter to 1 kilometer? C. 1 to 100,000. There's 100,000 centimeters in 1 kilometer. Number 5. A. Find 3 different ratios that are equivalent to 7 to 3. A ratio of 7 to 3 is equivalent to a ratio of 14 to 6, 21 to 9, and 28 to 12. B. Explain why these ratios are equivalent. 7 times 2 is 14 and 3 times 2 is 6. 7 times 3 is 21 and 3 times 3 is 9. 7 times 4 is 28 and 3 times 4 is 12. Since the 7 and the 3 are both multiplied by 2, 3, and 4 respectively, they are equivalent ratios. Seventh grade, Unit 2, Lesson 2, Introducing Proportional Relationships with Tables. There are a couple key glossary terms in this unit. The first term that you need to know is constant of proportionality. In a proportional relationship, the values for one quantity are each multiplied by the same number to get the values for the other quantity. This number is called the constant of proportionality. In this example, the constant of proportionality is 3, because 2 times 3 equals 6, 3 times 3 equals 9, and 5 times 3 equals 15. This means that there are 3 apples for every 1 orange in the fruit salad. The second important term that you should know is proportional relationship. In a proportional relationship, the values for one quantity are each multiplied by the same number to get the values for the other quantity. For example, in this table, every value of P is equal to 4 times the value of S on the same row. We can write this relationship as P equals 4S, or P equals 4 times S. This equation shows that P is proportional to S. Number 1. When Han makes chocolate milk, he mixes 2 cups of milk with 3 tablespoons of chocolate syrup. Here is a table that shows how to make batches of different sizes. Use the information in the table to complete the statements. Some terms are used more than once. A. The table shows a proportional relationship between blank and blank. The table shows a proportional relationship between cups of milk and tablespoons of chocolate syrup. B. The scale factor shown is, the scale factor shown is 4, because 2 times 4 is 8 and 3 times 4 is 12. C. The constant of proportionality for this relationship is 3/2, or 1.5, because for every 1 cup of milk, there's 3/2, or 1.5 tablespoons of chocolate syrup. D. The units for constant of proportionality are blank per blank. The units of the constant of proportionality are tablespoons of chocolate syrup per cup of milk. Number 2. A certain shade of pink is created by adding 3 cups of red paint to 7 cups of white paint. A. How many cups of red paint should be added to 1 cup of white paint? 7 cups of white paint divided by 7 cups of white paint equals 1 cup of white paint, and 3 cups of red paint divided by 7 equals 3/7 cups of red paint. B. What is the constant of proportionality? Since there's 1 cup of white paint for every 3/7 cups of red paint, the constant of proportionality is 3/7. Number 3. A map of a rectangular park has a length of 4 inches and a width of 6 inches. It uses a scale of 1 inch for every 30 miles. A. What is the actual area of the park? Show how you know. On the scale drawing, or on the map, the length is 4 inches and the width is 6 inches. Since it uses a scale of 1 inch for every 30 miles, the length of the actual park is 4 times 30 and the width is 6 times 30. The length of the actual park is 120 miles and the width of the park is 180 miles. To find the area of the park, we have to multiply the length times the width, or 120 miles times 180 miles. 120 times 180 is 21,600, so the actual area of the park is 21,600 square miles. B. The map needs to be reproduced at a different scale so that it has an area of 6 square inches and can fit in a brochure. At what scale would the map need to be reproduced so that it fits on the brochure? Show your reasoning. What this is saying is that 21,600 square miles needs to be represented in an area of 6 square inches so that it will fit in a brochure. Take the area, 21,600, and divide it by 6, and that would be 3,600. Since 60 times 60, or 60 squared, equals 3,600, the new scale would be 1 inch to 60 miles, or 1 inch for every 60 miles. Number 4. Noah drew a scaled copy of polygon P and labeled it polygon Q. If the area of polygon P is 5 square units, what scale factor did Noah apply to polygon P to create polygon Q? Explain or show how you know. On the left side is polygon Q with an area of 45 square units, and on the right side is polygon P with an area of 5 square units. I labeled a length on polygon Q 3 units, and I labeled its corresponding length of 1 unit on polygon P. To go from a length of 1 unit on polygon P to 3 units on polygon Q, that would increase by a scale of 3, so the scale factor is 3. Number 5. Select all the ratios that are equivalent to each other. Let's start with the ratio 4 to 7. 4 times 2 is 8, and 7 times 2 is 14. 4 times 3 is 12, and 7 times 3 is 21. 4 times 4 is 16, and 7 times 4 is 28. 4 times 5 is 20, and 7 times 5 is 35. Now select all the ratios that they provided that are also in the ratio list that I created. A, 4 to 7, C, 16 to 28, and E, 20 to 35. Seventh grade, Unit 2, Lesson 3. More about constant of proportionality. Number 1. Noah is running a portion of a marathon at a constant speed of 6 miles per hour. Complete the table to predict how long it would take him to run different distances at that speed, and how far he would run in different time intervals. If the time in hours was 1 and he's running 6 miles per hour, then the miles traveled at 6 miles per hour would be 6. If the time in hours was a half hour, 1/2 is half of 1, so half of 6 would be 3. At 6 miles per hour, the distance traveled after 1/2 hour would be 3 miles. The next amount of time is a little bit trickier. It's 1 1/3 hours. One way to figure this out is to figure out how far he would travel in 1/3 of an hour. If he travels 6 miles in 1 hour, then he would travel 1/3 of 6 miles in 1/3 of an hour. Imagine this block represents 6. When we cut this block into 3 equal pieces, each piece is worth 1/3 of 6. 2 plus 2 plus 2 equals 6. So 1/3 of 6 is 2. So in 1/3 of an hour, he could run 2 miles. At 6 miles an hour, in 1 hour, he could run 6 miles. And in 1/3 of an hour, he can run 2 miles. So if he ran 6 miles an hour for 1 1/3 hour, he could run 8 miles. Since this one looks easier, I'm going to skip down to 9 miles traveled at 6 miles per hour. 9 is equal to 6 plus 3. Since he ran 6 miles in 1 hour and he ran 3 miles in a half hour, he would have run 9 miles in a total of 1.5 hours. One way to figure out 4.5 miles traveled at 6 miles per hour is 4.5 is exactly half of 9. So 9 divided by 2 equals 4.5, and 1.5 divided by 2 equals 3/4 of an hour. 1.5 miles traveled at 6 miles per hour is 3 times less than 4.5 miles traveled at 6 miles per hour, because 1.5 plus 1.5 plus 1.5 equals 4.5. We can divide 4.5 by 3 to get 1.5, and we'd have to divide 3/4 by 3 to get 1/4. So at 1.5 miles traveled at 6 miles an hour, it would have taken him 1/4 of an hour. Number 2, 1 kilometer is 1,000 meters. A. Complete the tables. What is the interpretation of the constant of proportionality in each case? 1,000 meters for every 1 kilometer, or 1 kilometer for every 1,000 meters. This information tells me that 1 kilometer is equal to 1,000 meters. So I have to ask myself, what's 1,000 times smaller than 250? 25 hundredths is 1,000 times smaller than 250. For every 250 meters, you would have 25 hundredths of a kilometer. What's 1,000 times smaller than 12? 12 thousandths is 1,000 times smaller than 12. So 12 meters is a distance of 12 thousandths of a kilometer. What's 1,000 times smaller than 1? 1 thousandths is 1,000 times smaller than 1. So for every 1 meter, it's 1 thousandths of a kilometer. On this table, 1 kilometer represents 1,000 meters. So for every 5 kilometers, I would have 5 times 1,000 meters. 1 kilometer equals 1,000 meters, 5 kilometers equal 5,000 meters. For every 20 kilometers, how many meters would you have? 1 times 20 is 20, and 1,000 times 20 is 20,000. So for every 20 kilometers, you'd have 20,000 meters. 3/10 of a kilometer would equal how many meters? Well, 3/10 times 1,000 is 300. So for every 3/10 of a kilometer, you would have 300 meters. The constant of proportionality, tell us that. For the left table, the constant of proportionality is 1,000ths of a kilometer per meter. For the right table, the constant of proportionality is 1,000 meters per kilometer. Number 3. Jada and Lynn are comparing inches and feet. Jada says that the constant of proportionality is 12. Lynn says it is 1/12. Do you agree with either of them? Explain your reasoning. What Jada means is that there's 12 inches per foot, so I would agree with her. And what Lynn means is that there's 1/12 of a foot per inch, so I can also agree with Lynn. Number 4. The area of the Mojave Desert is 25,000 square miles. A scale drawing of the Mojave Desert has an area of 10 square inches. What is the scale of the map? If 10 square inches represents 25,000 square miles, then 1 square inch represents 2,500 square miles. Since 1 squared is 1 and 50 squared is 2,500, then the scale is 1 inch to 50 miles. Number 5. Which of these scales is equivalent to the scale 1 centimeter to 5 kilometers? Select all that apply. A. 3 centimeters to 15 kilometers. That's equivalent to 1 centimeter to 5 kilometers. 1 times 3 is 3, and 5 times 3 is 15. D. 5 millimeters to 2 5/10 kilometers is equivalent to the scale of 1 centimeter to 5 kilometers. 1 centimeter divided by 2 equals 5 millimeters, and 5 kilometers divided by 2 equals 2 5/10 kilometers. E. 1 millimeter to 500 meters. That's equivalent to the scale of 1 centimeter to 5 kilometers. 1 centimeter divided by 10 equals 1 millimeter, and 5 kilometers divided by 10 equals 500 meters. Number 6. Which one of these pictures is not like the others? Explain what makes it different using ratios. The width of this portion of L is 3 units, the width of that same portion for M is 4 units, and the width of that portion for N is 9 units. The height of that section for L is 4 units, the height of that section for M is 8 units, and the height of that section for N is 12 units. The ratios are 3 to 4, 4 to 8, and 9 to 12. The 3 to 4 ratio is equivalent to a 9 to 12 ratio. 3 is 3/4 of 4, and 9 is 3/4 of 12. So pictures L and N are alike, and picture M is not alike because 4 is half of 8 and not 3/4 of 8. Help me disrupt YouTube's algorithm by liking this video, commenting on this video, sharing this video, and subscribing to my channel. Thanks. I appreciate it. 7th grade, Unit 2, Lesson 4, Proportional Relationships and Equations. Number 1. A certain ceiling is made up of tiles. Every square meter of ceiling requires 10 75/100 tiles, or 10.75 tiles. Fill in the table with the missing values. Outlined in red, you can see that every square meter of ceiling tile requires 10.75 tiles. That's almost 11 tiles. So 1 square meter of ceiling requires 10.75 tiles. Multiply the 1 times 10 to get 10 square meters, and multiply 10.75 times 10 to get 107 5/10 tiles. That's 10 times bigger than 10.75. So for every 10 square meters of ceiling, you would need 107 1/2 ceiling tiles. To find out how many square meters of ceiling would hold 100 tiles, we need to divide 100 by 10 and 75 hundredths, and that's approximately 9.3 or 9 3/10. So for 9 3/10 square meters of ceiling, it would take approximately 100 ceiling tiles. Since the constant of proportionality is the square meters of ceiling times 10 and 75 hundredths, then A times 10 and 75 hundredths would equal the number of tiles needed for A, the unknown square meters of ceiling. Number 2. On a flight from New York to London, an airplane travels at a constant speed. An equation relating to the distance traveled in miles, d, to the number of hours flying, t, is t equals 1 over 500 times distance, or t equals 1/500ths d. How long will it take the airplane to travel 800 miles? This equation means that the time the trip will take would be equal to 1/500th of the distance traveled. Since the distance traveled is 800 miles, the time would be 1/500th of 800 miles. And that's the same as 800 divided by 500. 800 divided by 500 equals 1 6/10. It will take the airplane 1 6/10 hours to travel 800 miles. Number 3. Each table represents a proportional relationship. For each, find the constant of proportionality and write an equation that represents the relationship. The constant of proportionality for this first table would be P divided by S, or in the case of the top row, it would be 8 divided by 2. 8 divided by 2 is 4. The constant of proportionality is 4. We can test this out. The constant of proportionality times S equals P. 4 times 2 equals 8. We can show this relationship for all the values in the table. Four times 3 is 12, 4 times 5 is 20, and 4 times 10 is 40. To write an equation that represents the relationship, we can substitute these terms with the variable s and substitute these terms with the variable p. The equation reads 4 times s equals p, or 4s equals p. 4s equals p can also be written as p equals 4s. For the table on the right, we need to find the constant of proportionality, and we need to write an equation to represent the value of c. c divided by d would tell us the constant of proportionality. 6 28 hundredths divided by 2 equals 3 14 hundredths. So the constant of proportionality is 3.14. We divided 6.28 by 2 to get 3.14. Now we have to divide 2 by 2, and that gives us 1. So when the value for D is 1, the value for C is 3.14. So the equation would read C equals 3.14 times D, which is the same as C equals 3.14 D. Number 4. A map of Colorado says the scale is 1 inch to 20 miles, or 1 to 1,267,200. Are these two ways of reporting the scale the same? Explain your reasoning. Sure they are, and let me try to explain why. They started out by saying that the scale is 1 inch to 20 miles, and I already know that there are 12 inches to 1 foot. And I looked it up and discovered that there are 5,280 feet to every mile. We can multiply 5,280 feet times 12 to find out how many inches would be in 1 mile. So there's 63,360 inches in 1 mile. Now all we have to do is multiply 1 mile times 20 to get 20 miles, and multiply 63,360 inches times 20, and we discovered that there's 1,267,200 inches in 20 miles. So to say that the scale is 1 inch to 20 miles or 1 to 1,267,200, either one would be correct, so they are the same. Number 5. Here is a polygon on a grid. A. Draw a scaled copy of the polygon using a scale factor of 3. Label the copy A. Using a scale factor of 3 would mean that all the side lengths of the copy would be 3 times longer than the side lengths of the original figure. This red side length on the original figure is 2 units long, and the side length on the copy would be 2 times 3 or 6 units long. I'll repeat this process for each line of the original figure, making the side lengths on the copy 3 times longer. Here's a look at the scaled copy with the scale factor of 3 labeled A. B. Draw a scaled copy of the polygon with a scale factor of 1/2. Label it B. This time the side lengths of the scaled copy will be exactly 1/2 the length of the original figure. Here's a look at the scaled copy with the scale factor of 1/2 labeled B. C. Is polygon A scaled copy of polygon B? If so, what is the scale factor that takes B to A? Figure A can be considered a scale copy of figure B because all the side lengths on figure A are exactly 6 times longer than all the side lengths on figure B. The scale factor is 6. Show me some love. Like, comment, share, and subscribe. Seventh grade, Unit 2, Lesson 5. 2 equations for each relationship. Number 1. The table represents the relationship between a length measured in meters and the same length measured in kilometers. A. Complete the table. Well, we know that 1,000 meters equals 1 kilometer. So a meter is 1,000 times smaller than a kilometer. If 1,000 meters equals 1 kilometer, then 3,500 meters would equal 3 5/10 kilometers. 500 is half of 1,000, so if 1,000 meters equals 1 kilometer, then 500 meters would equal a half a kilometer, or 5/10 of a kilometer. I'm noticing a pattern. The decimal point is being moved to the left 3 places to make that value 1,000 times smaller. 75 meters equals 75 thousandths of a kilometer, and 1 meter equals 1,000ths of a kilometer, and x meters equals 1,000ths times x kilometers. B. Write an equation for converting the number of meters to kilometers. Use x for number of meters and y for number of kilometers. The equation would be y equals 1,000ths times x. Number 2. Concrete building blocks weigh 28 pounds each. Using B for the number of concrete blocks and W for the weight, write 2 equations that relate the 2 variables. One equation should begin with W equals, and the other should begin with B equals. I'm going to use the equation y equals kx to help me get started. The k, in this case, is 28 for 28 pounds. The y in this case is represented by the w for the total weight of all the blocks. And the x is represented by a b for the number of concrete blocks. So w equals 28b, or w equals 28 times b. Since there are 2 equations for each relationship, I'm going to use this equation to help me get started. X equals 1 divided by k times y, or x equals 1 over k times y. The x will be represented with the b blocks for the number of concrete blocks. I'll replace the y with the w to represent the total weight. And the K, or the constant, would be the 28, representing the 28 pounds each block weighs. So the second equation would be B equals 1 over 28 times W, or B equals 1 divided by 28 times W. Number 3. A store sells rope by the meter. The equation P equals 8/10 L represents the price P in dollars of a piece of nylon rope that is L meters long. A. How much does the nylon rope cost per meter? The key piece of information is the price equals 8/10 times the length. When the length is 1 meter, then the price is 8/10 times 1. And 8/10 times 1 is 8/10. So the price for the rope is 80 cents per meter. B. How long is a piece of nylon rope that costs $1? What I learned when working on A was that P equals 8/10 times L. Since there's two equations for each relationship, I can also look at this as L equals 1 over 8/10, or L equals 1 divided by 8/10. And 1 divided by 8/10 is 1 25/100, or 1 1/4. So the length of a piece of nylon rope that costs $1 is 1 25/100 meters long, or 1 1/4 meters long. Number 4. The table represents a proportional relationship. Find the constant of proportionality and write an equation to represent the relationship. When A equals 2 and Y equals 2/3, then when A equals 1, Y would equal 1/3, because 2 divided by 2 is 1, and 2/3 divided by 2 is 1/3. The constant of proportionality is 1/3. An equation to represent this relationship is Y equals 1/3 A, or Y equals 1/3 times A, which is also equivalent to Y equals A divided by 3. Number 5. On a map of Chicago, 1 centimeter represents 100 meters. Select all statements that express the same scale. B represents the same scale because 1 centimeter divided by 10 equals 1 millimeter, and 100 meters divided by 10 equals 10 meters. C represents the same scale because 1 centimeter times 10 equals 10 centimeters, and 100 meters times 10 equals 1 kilometer. A does not represent the same scale because 1 centimeter times 5 equals 5 centimeters, but 100 meters times 5 does not equal 50 meters. And D does not represent the same scale because 1 centimeter times 100 equals 100 centimeters, but 100 meters times 100 does not equal 1 meter. Seventh grade, Unit 2, Lesson 6, Using Equations to Solve Problems. Number 1. A car is traveling down a highway at a constant speed, described by the equation d equals 65t, where d represents the distance in miles that the car travels at this speed in t hours. A. What does the 65 tell us in this situation? D equals 65t. The car is traveling at a constant speed of 65 miles per hour. B. How many miles does the car travel in 1 5/10 hours, or 1.5 hours? In 1 hour, the car travels 65 miles, so a half hour would be half of 65 miles. A half hour would equal 32 5/10 miles. In 1.5 hours, the car would travel 65 miles plus 32 5/10 miles. The car would travel 97 5/10 miles in 1.5 hours. C. How long does it take the car to travel 26 miles at this speed? 65 miles in 1 hour, and to get from 65 to 1, we need to divide 65 by 65. Since we divided the miles by 65, we have to divide the hours by 65. 1/65 of an hour, or 1 over 65. To turn the 1 mile into 26 miles, we need to multiply the 1 times 26. And since we've multiplied 1 mile times 26, we need to multiply 1/65 of an hour times 26. And 1/65 of an hour times 26 is the same as 1 divided by 65 times 26, which is 4/10. It would take a car traveling at this speed 4/10 of an hour to travel 26 miles. 4/10 is equivalent to 2/5 or 24 minutes. Number 2, Elena has some bottles of water that each hold 17 fluid ounces. A. Write an equation that relates the number of bottles of water, B, to the total volume of water, W, in fluid ounces. W equals 17B. Another equation could be B equals 1/17 W. B. How much water is in 51 bottles? 17 multiplied by 51 equals 867. There is 867 fluid ounces in 51 bottles of water. C. How many bottles does it take to hold 51 fluid ounces of water? 51 divided by 17 equals 3. It takes 3 bottles to hold 51 fluid ounces of water. Number 3. There are about 1 61/100 kilometers in 1 mile. Let x represent a distance measured in kilometers and y represent the same distance measured in miles. Write 2 equations that relate a distance measured in kilometers and the same distance measured in miles. In the left column, we have kilometers, or x, at 1 61/100. On the right-hand column, we have miles, or y, at 1. X equals 1 61/100 y, and the other equation would be y equals 1 over 1 61/100 x. Number 4. In Canadian coins, 16 quarters is equal in value to 2 toonies. A. Fill in the table. Well, the table tells us that 16 quarters equals 2 toonies. To turn the 16 into a 1, we need to divide the 16 by 16 to make 1. Since we divided 16 by 16, we also need to divide 2 by 16. And 2 divided by 16 equals 2/16, which is equivalent to 1/8. 1/8 is also 125 thousandths, or 0.125. 1 times 20 equals 20, and 1/8, or 125 thousandths, times 20 equals 2 5/10, or 2.5. Next, we need to fill in this last empty space. 1 times 24 equals 24, and 1/8, or 125 thousandths, times 24 equals 3. B. What does the value next to 1 mean in this situation? 1/8 means that 1/8 of a toonie is equal to 1 quarter. Number 5. Each table represents a proportional relationship. For each table, A, fill in the missing parts of the table. If 2x equals 10y, then 1x would equal 5y, since 1 is half of 2 and 5 is half of 10. 1x times 7 equals 7x, and 5y times 7 equals 35y. 1 times 3 equals 3, or 1x times 3 equals 3x, and 5 times 3 equals 15, or 5y times 3 equals 15y. 12 divided by 12 equals 1. 3b divided by 12 would equal 3 over 12, or 3 divided by 12. 3 over 12 is the same as 1/4. 40 equals 10, or 40a equals 10b. Since 20 is half of 40 and 5 is half of 10, 20a would equal 5b. On the right-hand table, 5m equals 3n. Since 10 is twice the value of 5, we need to figure out what's twice the value of 3, and twice the value of 3 is 6. 5 times 6 is 30, and 3 times 6 is 18. And 5 divided by 5 is 1, and 3 divided by 5 is 3/5. B. Draw a circle around the constant of proportionality. On the first table, the constant of proportionality is 5. On the second table, the constant of proportionality is 1/4. And on the third table, the constant of proportionality is 3/5. Number 6. Describe some things you could notice in two polygons that would help you decide that they were not scaled copies. They would not be scaled copies if they were different shapes. Example, one was a rectangle and one was a triangle. They would not be scaled copies if they had different angle measures. Seventh grade, Unit 2, Lesson 7, Comparing Relationships with Tables. Number 1. Decide whether each table could represent a proportional relationship. If the relationship could be proportional, what would the constant of proportionality be? A. How loud a sound is depending on how far away you are. This is a ratio of 5 to 85. This is a ratio of 10 to 79. This is a ratio of 20 to 73. And this is a ratio of 40 to 67. These are not proportional because the ratio of distance to listener to sound level is not equivalent every time. B. The cost of fountain drinks at Hot Dog Hut. A ratio of 16 ounces to $1.49. 20 ounces to $1.59, and 30 ounces to $1.89. These are not proportional because the ratio of volume to cost is not equivalent each time. Number 2. A taxi service charges $1 for the first 1/10 of a mile, then 10 cents for each additional 1/10 mile after that. Fill in the table with the missing information, then determine if this relationship between the distance traveled and the price of the trip is a proportional relationship. When the distance traveled is 9/10 of a mile, that's the same as 1/10 plus 8/10. And that 1/10 could be considered $1 for the first 10th of a mile, and the 8/10 of a mile would be considered 8 dimes or 80 cents. So $1 plus 80 cents is $1.80. The taxi would charge $1.80 to go 9/10 of a mile. when the distance traveled is 2 miles. That's the same as 20 tenths. And one of those tenths would be used for the first tenth of a mile, which would be $1, leaving 19 tenths left over, or 19 dimes. And 19 dimes is $1.90. So $1 for the first tenth added to $1.90 would be a total of $2.90 to travel 2 miles. When the distance traveled is 3 1/10 mile. That's the same as 31 tenths of a mile. The first tenth would be $1, leaving 30 tenths left over, or 30 dimes. And 30 dimes is $3. So $1 plus $3 is $4. To travel 3 1/10 mile, it would cost $4. When the distance traveled is 10 miles, that's the same as 100 tenths. And the first tenth would cost $1, leaving 99 tenths left over, which is the same as 99 dimes. And 99 dimes is equivalent to $9.90. So $1 plus $9.90 would equal $10.90. So when the distance traveled is 10 miles, the taxi would charge $10.90. Now we need to determine if the relationship between the distance traveled and the price of the trip is a proportional relationship. This is not a proportional relationship because the ratio of price to distance traveled is not equivalent each time. Number 3. A rabbit and turtle are in a race. Is the relationship between distance traveled and time proportional to either one? If so, write an equation that represents the relationship. The turtles run a distance of 108 to 2. That's a 54 to 1 ratio. 2 divided by 2 is 1, and 108 divided by 2 is 54. A distance of 405 and 7 5/10 minutes. 7 5/10 minutes divided by 7 5/10 equals 1, and 405 divided by 7 5/10 equals 54. So this is also a ratio of 54 to 1. 10 divided by 10 is 1, and 540 divided by 10 is 54. So this is also a ratio of 54 to 1. And finally, 32 75/100 divided by 32 75/100 equals 1. And 1,768 5/10 divided by 32 75/100 is 54. For the turtles run, the relationship between distance traveled and time is proportional. And now for the rabbit. Distance traveled 800 meters to the time in minutes. 1 minute, 800 to 1. Time in minutes, 5 divided by 5 equals 1, and 900 divided by 5 is the same as 180. This is a 180 to 1 ratio. We can already tell that the relationship between the distance traveled and the time is not proportional for the rabbit's run, because 800 to 1 is a different ratio than 180 to 1. So now we need to write an equation that represents the relationship of distance and time for the turtle's run. The distance is proportional to the time only for the turtle. An equation could be d equals 54t, or d equals 54 times t, where d represents the distance traveled in meters and t is the time in minutes. Number 4. For each table, answer, what is the constant of proportionality? Table A. 14 divided by 2 is 7. 35 divided by 5 is 7. 63 divided by 9 is 7. And 7/3 divided by 1/3 is also 7. So the constant of proportionality for Table A is 7. Table B. 360 divided by 3 is 120. 600 divided by 5 is also 120. 960 divided by 8 is 120. And finally, 1,440 divided by 12 is 120. So for Table B, the constant of proportionality is 120. Table C. 3 divided by 75. That's the same as the fraction 3 over 75, or 3/75, which can be reduced to 1/25. 8 divided by 200, that's the same as 8 over 200, which can be reduced to 1/25. 61 divided by 1,525, that's 61 over 1,525, and that can be reduced to 1/25. And finally, 4/10 divided by 10. 4/10 over 10, or 4/10 divided by 10, is 1/25. So the constant of proportionality for table C is 1/25. Table D, 10 divided by 4. 10 over 4, or 10/4, is equivalent to 2.5. 15/6. 15/6, or 15 divided by 6, is equivalent to 2.5. 55 divided by 22. 55 over 22, or 55 divided by 22, is also equivalent to 2.5. And then finally, 7.5 divided by 3. 7.5 divided by 3 is equivalent to 2.5. So for table D, the constant of proportionality is 2.5. Number 5. Kieran and Meyer standing at one corner of a rectangular field of grass, looking at the diagonally opposite corner. Kieran says that if the field were twice as long and twice as wide, then it would be twice the distance to the far corner. Mai says that it would be more than twice as far, since the diagonal is even longer than the side lengths. Do you agree with either of them? Twice as long and twice as wide is equivalent to a scale factor of 2. In this case, the rectangle would be 2 times larger. Kieran is correct. Scale the length and width of a rectangle by a factor of 2, and the diagonal will also scale by a factor of 2. Seventh grade Illustrative Math, Unit 2, Lesson 8, Comparing Relationships with Equations. Number 1. The relationship between a distance in yards, y, and the same distance in miles, m, is described by the equation y equals 1,760 m. A. Find measurements in yards and miles for distances by filling in the table. This table has distances measured in miles on the left and distances measured in yards on the right. I'll label them M and Y. 1 times 1,760. So there's 1,760 yards in 1 mile. 1 times 5 equals 5, and 1,760 times 5 equals 8,800. So there's 8,800 yards in 5 miles. 3,520 yards divided by 1,760 equals 2. So every 3,520 yards, there's 2 miles. 17,600 yards divided by 1,760 yards equals 10. So for every 17,600 yards, there's 10 miles. B. Is there a proportional relationship between a measurement in yards and a measurement in miles for the same distance? Explain why or why not. The distance increases 1,760 yards for every mile. Yes, there is a proportional relationship. The constant of proportionality is 1,760 yards per mile. Number 2. Decide whether or not each equation represents a proportional relationship. A. The remaining length of a 120-inch rope after X inches have been cut off. 120 minus X equals L. This subtraction sign tells me that it's not going to be a proportional relationship. B. The total cost, T, after 8% sales tax is added to an item's price. t. 1 8/100 times the price equals t. Since we're multiplying 1 8/100 times p, that tells me that it will be a proportional relationship. C. The number of marbles each sister gets, x, when m marbles are shared equally among 4 sisters. X equals m divided by 4. X equals m divided by 4 is the same thing as 4 times x equals m. So if there's a division sign or a multiplication sign, it tells me that there will be a proportional relationship. D. The volume, V, of a rectangular prism whose height is 12 centimeters and base is a square with side lengths s centimeters. V equals 12s squared, or V equals 12s to the second power. Since there's an exponent here, it tells me that there will not be a proportional relationship. Number 3. A. Use the equation y equals 5/2 x to fill in the table. Is y proportional to x and y? Explain why or why not. Y equals 5/2 x. So 5/2 is the same as 2.5 because 5 divided by 2 is 2.5. So y equals 2.5 multiplied by x. When x is 2, it's the same thing as y equals 2.5 multiplied by 2. And 2.5 multiplied by 2 is the same thing as 2 plus 2 plus half of 2, or 1. So 2 plus 2 plus 1 is 5. When the value for x is 3, it's the same thing as y equals 2.5 multiplied by 3, or 3 plus half of 3. And since half of 3 is 1 5/10, you can find the answer by adding 3 plus 1 5/10, and that is 7 5/10. When the value for x is 3, the value for y will be 7 5/10. When the value for x is 6, it would be y equals 2.5 multiplied by 6, or 6 plus half of 6. And 6 plus 6 plus 3 is 15. When the value for x is 6, the value for y will be 15. Is y proportional to x and y? Explain why or why not. Yes, y is proportional to x because y divided by x is equivalent to 5 divided by 2 in each row of the table. B. Use the equation y equals 3 2/10 times x plus 5 to fill in the table. Is y proportional to x and y? Explain why or why not. It says here y equals 3 2/10 times x plus 5. Y equals 3.2 multiplied by 1 and add 5. 3 2/10 multiplied by 1 is 3 2/10. Now all we have to do is add 5. That is 8 2/10. When x equals 2, y equals 3 2/10 multiplied by 2 and add 5. And that equals 6 4/10 plus 5, because 3 2/10 times 2 is 6 4/10. And 6 4/10 plus 5 is 11 4/10. So when the value for x is 2, the value for y is 11 4/10. When the value for x is 4, y equals 3 2/10 multiplied by 4 and add 5. 3 times 4 equals 12, and 2/10 times 4 equals 8/10. So 12 plus 8/10 plus 5, and that equals 17 8/10. When the value for x is 4, the value for y will be 17 8/10. Is y proportional to x and y? Explain why or why not. No, y is not proportional to x because y divided by x has a different value in each row of the table. For example, if you look at the table now, you see a value of 1 for x and a value of 8 2/10 for y. If we double the value for x, or we double 1, we get 2. But if we double y, or double 8 and 2/10, we would get 16 and 4/10, not 11 and 4/10. Number 4. To transmit information on the internet, large files are broken into packets of smaller sizes. Each packet has 1,500 bytes of information. An equation relating packets to bytes of information is given by B equals 1,500 times P, where P represents the number of packets and B represents the number of bytes of information. A. How many packets would be needed to transmit 30,000 bytes of information? 30,000 bytes and 1,500 bytes of information per packet. That's 30,000 divided by 1,500 equals 20. So there would be 20 packets needed to transmit 30,000 bytes of information. B. How much information could be transmitted in 30,000 packets? 30,000 multiplied by 1,500, that's 45 million bytes. So 45 million bytes of information could be transmitted in 30,000 packets. C. Each byte contains 8 bits of information. Write an equation to represent the relationship between the number of packets and the number of bits. Each byte contains 8 bits. Write an equation to represent the relationship between the number of packets and the number of bits. So each byte contains 8 bits. 8 bits multiplied by 1,500 packets equals 12,000. The equation that would represent the relationship between the number of packets and the number of bits would be 12,000 times P, or 12,000 P. Seventh grade, Unit 2, Lesson 9, Solving Problems About Proportional Relationships. Problem number 1. For each situation, explain whether you think the relationship is proportional or not. Explain your reasoning. A. The weight of a stack of standard 8.5 by 11 copier paper versus number of sheets of paper. Yes, this situation is proportional. Each piece of paper has the same weight. To find the weight of the stack, multiply the number of sheets of paper by the weight of a single sheet of paper. B. The weight of a stack of different sized books versus the number of books in the stack. This situation is not proportional. Each book has different weight. The weight of the stack can't be determined by multiplying the number of books by the weight of one book. Problem number 2. Every package of a certain toy also includes 2 batteries. A. Are the number of toys and number of batteries in a proportional relationship? If so, what are the 2 constants of proportionality? If not, explain your reasoning. Let's make a table. On the left side, you'll have the number of toys, and on the right side, you'll have the number of batteries. 1 toy, 2 batteries. 2 toys, 4 batteries, and so on. This pattern shows the relationship is proportional. And the constants of proportionality is 1/2 and 2. The number of toys will be half the number of batteries. B. Use T for the number of toys and B for the number of batteries to write 2 equations relating the 2 variables. We can write the equation B equals 2T because the number of batteries always equals 2 times the number of toys. We can also write the equation T equals B over 2 because the number of toys is always equal to the number of batteries divided by 2. Or T equals 1/2 times B because the number of toys always equals half the number of batteries. Problem number 3. Lynn and her brother were born on the same date in different years. Lynn was 5 years old when her brother was 2. A. Find their ages in different years by filling in the table. To find her brother's age, we simply subtract 3. 5 minus 3 is 2, 6 minus 3 is 3, 15 minus 3 is 12. What number minus 3 is 25? 28 minus 3 is 25. So when Lynn was 5, her brother was 2. When she was 6, her brother was 3. When she's 15, her brother will be 12. And when her brother's 25, Lynn will be 28. B. Is there a proportional relationship between Lynn's age and her brother's age? Explain your reasoning. No, there is no proportional relationship between Lynn's age and her brother's age because every year they both get 1 year older and the ratio changes every year. Problem number 4 from 7th grade, Unit 2, Lesson 8. A student argues that y equals x over 9 does not represent a proportional relationship between x and y because we need to multiply one variable by the same constant to get the other one and not divide it by a constant. Do you agree or disagree with this student? I disagree because multiplying 1/9 is the same thing as dividing by 9. In this situation, y equals x divided by 9 would be the same as y equals 1/9 times x. Problem number 5 from 7th grade, Unit 1, Lesson 3. Quadrilateral A has side lengths 3, 4, 5, and 6. Quadrilateral B is a scaled copy of quadrilateral A with a scale factor of 2. Select all the following that are side lengths of quadrilateral B. Let's start by multiplying all the side lengths of quadrilateral A by 2. Now we can easily see that the side lengths for quadrilateral B will be 6, 8, 10, and 12. So we can choose B, 6, and D, 8. We would not choose 5, 7, or 9 because those aren't side lengths of quadrilateral B. Please take a moment to subscribe to my channel and leave a comment below. I appreciate it. Thanks for watching, and I'll see you next time. Seventh grade Illustrative Math, Unit 2, Lesson 10. Introducing graphs of proportional relationships. Glossary term, origin. The origin is the point 0, 0 in the coordinate plane. This is where the horizontal axis and the vertical axis cross. Number 1. Which graphs could represent a proportional relationship? Explain how you decided. Graphs A and C. These two graphs are of proportional relationships. They both are part of a straight line that passes through the origin. B is a curved line passing through the origin. D is a straight line, but it passes through the y-axis above the origin. Number 2. A lemonade recipe calls for 1/4 cup of lemon juice for every cup of water. A. Use the table to answer these questions. What does X represent? X represents the number of cups of water. What does Y represent? Y represents the number of cups of lemon juice. Is there a proportional relationship between X and Y? Yes, there is a proportional relationship between X and Y. B. Plot the pairs in the table in a coordinate plane. The x-axis represents cups of water. The y-axis represents cups of lemon juice. 1 cup of water, 1/4 cup of lemon juice. 2 cups of water, 1/2 cup of lemon juice. 3 cups of water, 3/4 of a cup of lemon juice. 4 cups of water, 1 cup of lemon juice. 5 cups of water, 1 1/4 cup of lemon juice, and 6 cups of water, 1 1/2 cups of lemon juice. Now that I plotted the pairs on the table, you can see that it's a proportional relationship because they make a straight line. Number 3. Decide whether each table could represent a proportional relationship. If the relationship could be proportional, what would be the constant of proportionality? A. The sizes you can print a photo. When the width of the photo in inches goes from 4 to 8, that's doubling 4, so 4 times 2 is 8. We'd have to do the same thing to the height of the photo. 6 times 2, that would equal 12, not 10. So we know that this is not a proportional relationship. This table is not proportional because the ratio of width to height are not always the same. B. The distance from which a lighthouse is visible. Remember, we need to decide whether this table could represent a proportional relationship. One way we can see if they're proportional is by dividing the height of the lighthouse by the distance it can be seen in miles. So 20 divided by 6 is 3 1/3. 45 divided by 9 is 5. 70 divided by 11 is 6.36, and so on. 93 divided by 13 is 7.30, and so on. And 150 divided by 16 is 9.375. So you notice that these are not the same. Since they're not the same, this table could not represent a proportional relationship. Number 4. Select all of the pieces of information that would tell you X and Y have a proportional relationship. Let Y represent the distance between a rock and a turtle's current position in meters, and X represent the number of minutes the turtle has been moving. A. Y equals 3 times X. B. After 4 minutes, the turtle has walked 12 feet away from the rock. C. The turtle walks for a bit, then stops for a minute before walking again. D. The turtle walks away from the rock at a constant rate. I chose A and D. A and D have proportional relationships. Y equals 3 times X matches with D. D says that the turtle walks away from the rock at a constant rate, and Y equals 3 times X represents a constant rate. I almost picked B, but then I noticed that B mentioned a distance of 12 feet and not 12 meters. The instructions mention meters, not feet. Open up Resources, Illustrative Mathematics. 7th grade, Unit 2, Lesson 11, Interpreting Graphs of Proportional Relationships. Problem number 1. There is a proportional relationship between the number of months a person has had a streaming movie subscription and the total amount of money they have paid for the subscription. The cost for 6 months is $47.94. The 0.6 and $47.94 is shown on the graph below. A. What is the constant of proportionality in this relationship? $47.94 divided by 6 equals $7.99. The constant of proportionality in this relationship is $7.99. B. What does the constant of proportionality tell us about this situation? It tells us that the service charge is $7.99 each month. C. Add at least 3 more points to the graph and label them with their coordinates. 1 and 7.99, 10 and 79.90, and 20 and 159.80. D. Write an equation that represents the relationship between C, the total cost of the subscription, and M, the number of months. This equation could be C equals 7 and 99/100ths times M. Problem number 2. The graph shows the amounts of almonds in grams for different amounts of oats in cups in a granola mix. Label the point 1 K on the graph, find the value of K, and explain its meaning. For 1 cup of oats, there are 25 grams of almonds. So in this case, the unknown K would be 25, and that represents 25 grams of almonds. Problem number 3 from 7th grade, Unit 2, Lesson 9. To make a friendship bracelet, some long strings are lined up. Then, one string is tied in a knot with each of the other strings to create a row of knots. A new string is chosen and knotted with all the other strings to create a second row. This process is repeated until there are enough rows to make a bracelet to fit around your friend's wrist. Are the number of knots proportional to the number of rows? Explain your reasoning. Yes, each row will have the same amount of knots on it. The number of knots is a multiple of the number of rows. Problem number 4 from 7th grade, Unit 2, Lesson 9. What information do you need to know to write an equation relating two quantities that have a proportional relationship? You need to know a constant of proportionality and variables for the quantities. Help me disrupt YouTube's algorithm by liking this video, commenting on this video, sharing this video, and subscribing to my channel. Thanks. I appreciate it. Seventh grade, Unit 2, Lesson 12, using graphs to compare relationships. Problem 1. Match each equation to its graph. 4 units up, 5 units over. So the rise was 4 units and the run was 5 units. That would be B, y equals 4/5 times x, or y equals 4/5 x. The second graph has a rise of 2 and a run of 3. That would be 2 over 3, D. Y equals 2/3 x. Graph number 3. Going up, the units are divided into 3 sections. Here's a rise of 1/3, 2/3, 3/3, 4/3. So the rise is 4/3 and the run is 1. So we're looking for 4/3 over 1. 4/3 over 1, or 4/3 divided by 1. That would be E. Y equals 4/3 x. The fourth graph. Going up, the units are divided into 4. Here's a rise of 1/4, 2/4, and 3/4. So the rise is 3/4 and the run is 3. With a rise of 3/4 and a run of 3, that's the same thing as 3/4 divided by 3. And 3/4 divided by 3 is 1/4. I would select C, y equals 1/4 x. Graph number 5. There's a rise of 2 units and a run of 1 unit. The rise is 2 and the run is 1. That's 2 over 1, or 2 divided by 1. And 2 divided by 1 is 2. So I would select A, y equals 2x. Graph number 6. There's a rise of 3 and a run of 2. With a rise of 3 and a run of 2, I would select F, y equals 3/2 x. Number 2. The graphs below show some data from a coffee shop menu. One of the graphs shows cost in dollars versus drink volume in ounces, and one of the graphs shows calories versus drink volume in ounces. A. Which graph is which? Give them the correct titles. Well, these numbers must stand for calories, because I couldn't imagine paying $50 to $350 for coffee, so it would make sense that these numbers represent calories. I'm going to call this the calorie versus volume graph, and the one above it will be cost versus volume. B. Which quantities appear to be in a proportional relationship? Explain how you know. The calories versus volume graph seems to be proportional, as each of the points are on a line that would go through the origin. Additionally, the number of calories would double as the volume doubles. C. For the proportional relationship, find the constant of proportionality. What does that number mean? The rise over run would be 150 over 10. That's 150 divided by 10, which equals 15 divided by 1, or 15. There would be 15 calories per ounce. The constant of proportionality is 15 calories per ounce. Number 3. Lynn and Andre biked home from school at a steady pace. Lynn biked 1 5/10 kilometers and it took her 5 minutes. Andre biked 2 kilometers and it took him 8 minutes. A. Draw a graph with two lines that represent the bike rides of Lynn and Andre. The x-axis represents time in minutes and the y-axis represents distance in kilometers. Andre's information is graphed in purple. He's gone 2 kilometers in 8 minutes. Lynn's graph is marked in blue. She's gone 1 5/10 kilometers in 5 minutes. B. For each line, highlight the point with coordinates 1, K, and find K. I've put a circle around the points at the 1 minute mark. Now I have to find the value for K. Andre's rise is 2 and his run is 8. So the rise over run for Andre would be 2 over 8. That's the same as 1/4 or 25 hundredths. K equals 25 hundredths for Andre. Lynn's rise is 1 5/10 and her run is 5. 1 5/10 over 5, or 1 5/10 divided by 5. 1 5/10 divided by 5 equals 3/10. For Lynn, K equals 3/10. C. Who was biking faster? Lynn was going a little faster, as she went 3/10 of a kilometer per minute, and Andre only traveled 25 hundredths of a kilometer per minute. It's a little bit easier to compare if we put that 0 in the hundredths place. So now we can look at it as 30 hundredths of a kilometer compared to 25 hundredths of a kilometer. Seventh grade, Unit 2, Lesson 13. Two graphs for each relationship. Problem number 1. At the supermarket, you can fill your own honey bear container. A customer buys 12 ounces of honey for $5.40. A. How much does honey cost per ounce? 12 ounces of honey costs $5.40. 1 ounce of honey would cost $5.40 divided by 12. 12 ounces of honey divided by 12 equals 1 ounce, and $5.40 divided by 12 equals 45 cents. So 1 ounce of honey costs 45 cents. B. How much honey can you buy per dollar? One way to figure this out would be $5.40 divided by $5.40 to equal $1, and 12 ounces divided by 5.4, which equals 2.22. So you can get approximately 2.2 ounces for $1. C. Write two different equations that represent this situation. Use H for ounces of honey and C for cost in dollars. The cost is 45 cents per ounce of honey, so the equation could read C equals 0.45 H. And since you can buy 2.2 ounces of honey for $1, you can write the equation H equals 2.2 C. D. Choose one of your equations and sketch its graph. Be sure to label the axes. The horizontal axis represents the cost, and the vertical axis represents ounces of honey. As you can see on this graph, $1 could buy 2.2 ounces of honey. That means that $3 could buy 6.6 ounces of honey. Problem number 2. The point 3 and 6/5 lies on the graph representing a proportional relationship. Which of the following points also lie on the same graph? Select all that apply. 6/5 compared to 3. 6/5 is 4/10 the size of 3. And the same can be said for A. 4/10 is 4/10 the size of 1. The same can also be said for B. 6/10 is 4/10 of 1.5. Let's look at C. 3 is 2.5 times larger than 6/5. Since 2.5 is not the same as 4/10, these points would not lie on the same graph. Let's look at D. 11/5 compared to 4. 11/5 is 55/100 the size of 4. And since 55/100 is not the same as 4/100, these points will also not lie on the line of the graph. Let's look at E. 6 compared to 15. 6 is 4/10 the size of 15. And since 4/10 is equal to 4/10, these points will lie on the same line of the graph. Problem number 3. A trail mix recipe asks for 4 cups of raisins for every 6 cups of peanuts. There is a proportional relationship between the amount of raisins, R, cups, and the amount of peanuts, P, cups, in this recipe. A. Write the equation for the relationship that has constant of proportionality greater than 1. Graph the relationship. The amount of peanuts equals 6/4 times the amount of raisins. The equation reads P equals 6/4R. In this graph, raisins are the horizontal axis and the peanuts are the vertical axis. For every 4 cups of raisins horizontally, there's 6 cups of peanuts vertically. B. Write the equation for the relationship that has constant of proportionality less than 1. Graph the relationship. The equation R equals 4/6P has a constant of proportionality less than 1, and here's a look at its graph. The horizontal axis represents the peanuts, and the vertical axis represents the raisins. For every 6 cups of peanuts, there's 4 cups of raisins. Problem number 4 from 7th grade, Unit 2, Lesson 11. Here is a graph that represents a proportional relationship. A. Come up with a situation that could be represented by this graph. Every 10 days, 5 houses are painted. B. Label the axes with the quantities in your situation. The horizontal axis is the number of days, and the vertical axis is the number of houses painted. C. Give the graph a title. I could title this graph, Number of Houses Painted in Days. D. Choose a point on the graph. What do the coordinates represent in your situation? I choose the point at coordinates 20 and 10. 20 represents the number of days, and 10 represents the number of houses painted. In 20 days, 10 houses were painted. Please take a moment to subscribe to my channel and leave a comment below. I appreciate it. Thanks for watching, and I'll see you next time.